In this video, I will go quickly over the window, a quick overview of the program, and I will show maybe some of the details that I will not go through in other versions, a little bit of historical background, why the program looks like it looks, because still it's still in the development. I looked into cleaning all the bugs, to changing the fit algorithm recently and adding the couple fit, very useful option. So here it's more about the user interface and the routine. Then I will include another videos, two videos probably, one separately at first steps of fit, and a second video is about the main process, the main routine. So in this video, firstly, the window. Here you see the text box with the file name, and unlike previous versions, you don't have to make any changes. You just click at open and then you load. Then here you have either fluence or temperature dependent measurements very carefully. For example, here I load the fluence dependent measurements at temperature, and then you can see the scan info, all parameters that I get. I get fluences. Those fluences I get from the file. You can see that in the file I have all of these headers and the same information I have here, and then the temperature I get from the window that I open. Then one click thing that I will go through, that let's say I have temperature measurement, and additionally for temperature measurement I have this ignore duplicate thing. This ignore duplicate was made for some previous data sets when we had measurements with manually changing temperature before there was automatic control of temperature was developed, and the step was equidistant. In this way we had to copy different scans to make sure that we have equidistant steps in the data set. So it takes a lot of time to load, but as you can see, initially it just some scans, for example here, they exactly duplicate. We did not make another scan. We just use the same scan for two temperature just for the map. In this way, right now you can ignore duplicate and load the file. You can see that it will be much less files. So instead of having all the scans, you will have scans only on the temperature that we measured. And additionally, if you still want to make map, you can save all files with equidistant interpolation by temperature. So here it calls equidistant interpolation. Why? In reality, it interpolates signal, but by temperature. For example, I can start from 9, and then I can go to the last one, 165, and then I can click with the step of 0.5, and I will still get the same interpolated map. This is good detail. Another quick detail that some scans, for example, here we had some issue, so you can delete current scan, here delete with the button delete, and then when you interpolate, it will not use that scan, but it's also important thing, so your map will not be corrupted by bad scans. This is for the loading. For the loading, you also have to shift for the model. That is due to the fact that our source term includes separately the electron-electron scattering, and the process of shifting I will show in the how it affects in the manual scans firstly. Then I will say a little bit about this section, about these fit parameters, default manual input. This is for the old version of fits. Right now, these parameters are still used, but the main parameters for the Adam optimizer for the gradient descent fit is already inside. These parameters they have very little effect. You don't have to change them. Default works fine. Then you will have these parameters A and B. Also here you don't have to change them. The main optimization is inside. This is more for the testing purposes of the program. If the program works correctly and is still here, the same with sum of squared errors, it will be shown in the parameters file later. Then you here, this is just, you can change the different scan and see the scan info, fluence, temperature, and then the first last position of the selected region. Here I can reduce the region by ignore more points, and you will see that here I will have another last point. Then this first point I can modify by, let's say, using another shift, and then you will see that I shift all of my region. So this is the parameters. Then A, B are thermoreflectance coefficients that you will fit to coincide the temperatures with transient reflectivity in this case. Then another two parameters are electron phonon coupling strength big G. It will be shown in this text box. Right now it's empty, it did not fit. And here you will see the tau electron after fit here. Then here you have all of the parameters. The parameters here are coupled. Most parameters from here go to both depth dependent and fit, but all parameters that go separately to fit are overwritten here, and then some parameters are not used for fit but just for depth dependent. I go into the TTM prerequisites into more depth about these parameters. A quick recap that fluence here for depth dependent, fluence here or in the header for fit, then the same with the temperature here, initial temperature for depth dependent, initial temperature here or from the file are for fits. Then all parameters used for both models, but debye, thermal conductivity and tau escape used only for depth dependent model. Then you have advanced fit. Here, this parameter is by default the biggest, pretty big value, you should not touch it. Then couple fit makes the fit not local, less local, more global. For example, without couple fit, you treat every single scan individually, but physically, you know that with changing temperature, with changing fluence, the adjacent scans should have close values because the physical properties are continuous. That's why you can include the nearest neighbor. So first, this is the coupling strength. First is less, from less to more. There are predefined properties, how much it couples. For example, for first option, only the nearest neighbors are used, and only the second and the third neighbor, for example, the first neighbor used only 40% strength of the scan. Here you use not only the first neighbor but also the second. So this scan affects 60%, and the next scan affects 15%. And then here you still use only two neighbors, but the first neighbor affects 80%. And the next 30%. Then you have here three text boxes. These are your fit limits. Here from to the most important ones. The middle one here also from to for both parameters. The middle one is not used anymore because it was before the first versions use grid fit. So you need not just bounds but also the step. And right now you don't need step, it's gradient descent, so step is automatically defined and step is adjusted depending on the gradient descent. And here also the iterations and steps around best fit, tau, adjust, G, tau, EE. This is from the old version. Right now it is not used. Here the main buttons is fit all, is for the advanced fit. Then you have the focus region, the region where you will fit. For example, in this place I will fit from 200 to let's say to 1100, and I need to open more points. Then for manual fit you have separately the same thing, you can fit manually a different region. This fit region needed both for this G tau AA, but also the fit corresponds to coincide the temperatures. Temperatures from to temperature model if to transient reflectivity, for example, here I can show quickly from this file that here you have the equation for this, that here your temperatures from two temperature models that you obtain with these two formulas, solving the Runge-Kutta equation, and here you have this coefficient A and B, and you need exact region where they fit. So most times that the electron temperature will define the first drop because it increases fast and then it equilibrates with lattice temperature, and then this plateau will define by the at which temperature it equilibrates, and the coefficient B will fit where your signal goes to this plateau. Then you have safe temperatures and heat capacities are more for testing purposes. All the files that you want to save, you can save by putting the check marks and fit all, or you can separately save files here, save options and which region, integration region for some quantities, for some averaged quantities you need to define. Usually I choose from 0 when you have your 0 in the model to some value when your temperature is already equilibrated, so your dynamics that describe two temperature model already equilibrated. And then the last region in the program is here, check 0 shift and check 0 open scan 1. Those are optional. I usually use only this one to check 0 shift for one scan and then I fit. The uncertainty is still there. Uncertainty depends on the noise of your data and how good you can identify the shift. However, it's important to note that this tau electron and 0 shift, those are different parameters. I will show it in the manual scan how they differ.